Today I want to look at a small game jam game that I've done last week. I made this for my own personal game jam. I just did it on my own. I just have generated with the help of AI with some game jam themes. And I just picked the one that I had the best idea for. And I set myself the goal of making a game, finish it, publish it in like 20 hours in work time. So not like a week or a weekend or something like that. So I just set a fixed amount of like work time that I have, and I just noted all of the start and end of my work sessions. And I made this game, I think, even in under like 20 hours or 1,200 minutes. I think I made it in like 1,050 minutes, something around that. So in like 18 hours. This is Zero Sum. Zero Sum is a small math-based card game where the goal is to create... Where's my mouse? There's my mouse. The goal is to you have like two stacks of numbers. You start on 10. And this is like you, and you have your opponent on the top side. You have the deck of cards here. You have these two numbers. The goal is to get your number down to 0 and prevent the enemy to reach 0. So just like a quick game, I reduce my number to 1. We also have like here stores, so I don't really have a good card to play. So I can, with right click or pressing the magnet button here, I can send my cards to the store, not play it on my deck. And with that I now have form with a store card. These store cards always get multiplied with the store value. And that store value then, depending on if it's a multiplication card, you multiply. So in this time I would turn to 4 times 2, which would be 8, and I would multiply 8 on the enemy. So this is like kind of a way to build your own multiplication division card. There are only times 2, times 3 on division 2 and division 3. Divisions always go on your deck. Multiplications always go on the enemy decks. I still only have minus and plus all. So like the type always get on who you're getting at. So all goes on both. Player goes always on me, enemy always on the enemy, and dynamic is depending on what's the most beneficial. So I think I want to rank. I should just play the store now. So let's just play the store now and get him out to 48. He pushes me even further up, so I push him up. Now I think I can play a -1. Okay, now we really need a division. So I would just try to get myself here. I have to divide for all, divide the player, and get the enemy up. I don't really have good divisions. I will store the -1. I'll just do -3. He has all division cards. I don't have any. So I will bet on a division store card here, and I will just get my store up. Exactly. This would be good. Yeah, I will play it now just to get myself down. -5. I don't want to play this now. I bring him up. I would prefer to wait to play it through Division 4 for all. I don't want to get him down that much. I will give me down to 2. Now I can play the Division 4 because Division 4, 2 divided to 4 in an integer way always reaches 0. So when you have a division, if you have a lower number, you always win. And he has a high one, so I just get the victory. That is the game. You also have a little sound. I haven't turned it on, and you can configure the volume down here. Yeah, that's a small game. It's very much random, based from the cards. We can look a little bit at the project. I have developed it in the Godot engine, which I really enjoy working with, I have to say. Most of the time I have, with the second project that I've done after that, I've run into a little bit of issues with some small bugs, but other than that, I really like the workflow and just how Godot runs, its speed is really nice. And just its tool set that is very easy to use, but also kind of very low level, which I really enjoy. So if I just want to go over very quickly things more so on the project side of this game, Zero Sum is a card game. So when we look more on the script side, there are basically 3, 4, 5. Let's begin somewhere else. I have designed this more like in an MVC style, so the model view controller side, so the data side and the visuals are split. So you have, for example, when we start with the card is just a resource, so it's just a data class that basically just has 3 values. Every card has the target, that's what you see on the bottom. It has the number, which number it is, and it has an operation. These are just the target and the operation is just enums that are created. You just have target player, others, all, choice, and store, and you have plus, minus, multiplication, and division operations. And then you just have helper functions to create random cards and to apply these cards for the normal value and for the store and for some preview things. Then of course you have the deck. The deck is also just a resource with basically just an array of cards and just some helper functions to create one. Actually, the deck, first I have then the deck created as like a resource. The deck that you play with is not randomly generated. I just pre-created it in the editor with all of the options that you have. Basically, most cards are just 1 to 5. Of course, no division and multiplication. There are no ×1 or division 1 cards. It would just be useless. And I'm taking this pre-created deck and then I'm shuffling it. So I'm making a copy of it. I'm shuffling it, so it's just randomly shuffled. But I also do some small tweaks when it comes to the deck, because you can have very early on, if it's just randomly shuffled, it's very easy to get plus players where you add your own counter and where you lower the enemy counter. It's very easy to get them very early on, and they're very useless at the early one. They are more useful in the later state, because in the later state, adding to your counter can make sense because you can be in negative numbers. There's no limit. You don't play 0 to infinity. You play in all integer numbers, so positive and negative numbers, so you can have a -5 or a -100, and then increasing your own number would make sense. And so you want plus player cards in the game, but they are quite disadvantaged to have them very early on. So for the first 18 cards, I'm basically searching out all plus player and minus enemy cards. And then if we are not having, if you're only finding 1 of each of them, I take them out except when they are not in here. So I leave 1 in if there's only 1 card. If there's only 1 player plus player or minus enemy card in the first 18 cards, I leave them in if there's just 1, except when you have them in the hand cards. The first 6 cards are like you draw 3 cards at the beginning, the enemy draws 6 cards at the beginning. And if they are in the enemy cards, I don't allow them in the first starting hands, but I do allow 1 of them in the first 18 cards. And when you have such of these cards, I just swap. So I just look at, is there some one of these cards in the first 18 cards? I just store like the indices, and then I find like an opposite card. So I search for player minus cards and enemy plus cards. And then I just swap them with the card on the other side of the deck. So I shuffle so that you only have more minus player and plus enemy cards at the start. And you have then, of course, in consequence, more plus player and minus enemy cards in the end of the deck. So it's a little bit more favored to not have as many useless cards in the beginning, because it's very much random. Then of course you have the player data. That's what the player is. The player just has the number, the player just has the storage, the player just has an array of hands, and then just some events, some signals, and everything else is just some helper function to set things, to raise some events, and to add and remove cards, and to raise these events. And then I have the big, you then have the big game control script that is that ties everything together. I also just have one scene, just like the game scene. I mean, if more scenes, I have like the cards as single scenes and the player counters and storage counters and stuff like that. But most of it is just like in the main scene because it's just a very small game, and the game control then basically manages all of the connection. And like if the player, like when we go to the start game script, this is like the function that executes when we start the game. What we do every game, we just create like the player and the enemy data. We just connect a lot of the signals. Then we have here our counters and storage counters. Those are these scenes. The visual aspects of them, again, the counters are in like the player data here. And then we create the deck. Then we do our smart shuffle here. Then we connect if our deck gets out of cards so that we can end the game. Then we have like the deck panel. The deck panel is this thing here. It's also the visual thing that then just also gets the deck and it just visualizes the state of the deck. Then here we're doing the drawing. We are drawing the first 6 cards, and then we hand them to the player and to the enemy. In like you hand one the player, one the enemy, one the player, one the enemy, stuff like that. And then we have the enemy controller. The enemy controller is the script that controls the turn and like the playing of the enemy. We just set them up, so we just give them the enemy, the player, and like what's the starting number. Then we just set the game active, and then we just have some state managing. It's kind of everything. Then we, of course, we are setting up all of these connections. So when the numbers change and when the player cards are added and removed. And so when player cards are added, we just create the card, and the card is then a visual card where we create the scene of the visual card. We set the data cards to the visual card. Then we just set if it's disabled or not. And then we just connect a lot of events, if it's pressed, if you do the right click, if you're hovering over it. And then we're adding the card just on the screen, and we just store that we have the card also in an array to just have a reference to it. And the card scene is like just like this little card with just like basically a button that acts for clicking and stuff, and you just have like an operation label and the number label and the target layer, and so just some layered stuff, and it's in that sense very simple. That is also used for the display of the enemy card on top. I'm not doing the enemy deck and showing that. I'm also not having any animations for the cards when you draw them. That was just a little bit too I thought it would be maybe go a little bit too far, maybe a little bit too stressful, and I have only the cards what I wanted to go in. When in the game control, we create the card again, where we were with creating the card. So here we are creating this card scene, the visual part, and the card control is just the visual part. We have again separated our data part of the card with the visual part of the card, and we just have connected when the player draws a card, we just create a visual aspect of the card and just hand it the data. And we're not doing this for the enemy. That's also the reason why I'm not having it shown that the enemy draws cards or have cards and chooses between some, because the handling of that is global in the game control, and didn't have like a hand scene that manages that for a player data. So I didn't bother with mirroring that on an enemy also, because it didn't have any animations. I didn't thought that would make much sense. Of course, when we remove something, when we're connected to the removing, if the player removes the card from the hand, we just basically delete the visual aspect. So in that sense, we just have our data part, and we only do things on the data side, and then we just have connected that with events to the UI aspect that is disconnected from that and just is a representation, and that connects just the output and the input through the input events with like the managing and the game control handles that. So we very much have a simple MVC model view control pattern that I use in this game. A lot of things are then very straightforward. I don't think I have to go into a lot of that. Playing the card, I don't think it's that very interesting. Maybe what we can look at, if you have the enemy controller, could be interesting to cover. So the enemy controller, as we have first scene is also set up in our start game function. When we start the game, we create the player, the enemy, the deck, connect everything, and here on the bottom, the enemy controller, for reference, is just a normal node with a script that runs in our scene. And we just have a reference in our game control here. And the enemy controller is, we just call a setup function where we just pass the current enemy player data and the starting number, like what's the number where the number start at. So the enemy has the current game state basically, which he's storing here. He's also storing like an evaluation dictionary. Here we have our setup function that is called, and we call in our game control. Let's look at the side how we are calling this in our game control class. We have the enemy play function. We call the enemy play function when the game controller says, I want the enemy to do its turn and play its card, or its users just plays a turn. And here we are calling the enemy controller play function. This responds an enemy play response that just gives us data about basically a little bit of what would happen, so what card was played. You can look at this here. This is just like a little subclass of the enemy controller. So it just has a card data, which card was played. It just gives us what target was the card played on, and then it tells us was this a store? Was there some storing involved in the play that the enemy did? Because based on that, we are reacting in our game controls. If the target's invalid, that means we actually haven't done a turn, and so we're just returning. We're not doing anything. We're not giving any feedback. Then we are here setting the enemy card control, that is this like feedback card on the top. We're just setting that to the card that was played. Then we have like the cards feedback. These are just responsible for the lines to bounce. So if I play a card, that will bounce a line from the middle of the cards to the verge, so that you always know, and from all cards to all of the effects, if I play all, it will go to both. These are like the feedbacks that I'm drawing here, and I have them on enemy side, I have them on player side. They are just spawning a trail line that I have done here. This thing just draws a line on this target here, and that just spawns just one of them and just moves it, animates it from the points that I give him here, or that are created inside of that, to where from which cards to like what targets that it will affect. So you just have a little bit of a visual feedback to give, and I just have that kept here in the function. Then we're just playing that the card is sounds that the card is played, and then we just have some other sound handling. And here on the bottom we have some combo handling. So the game actually has some if we damage the enemy, or the enemy damages us multiple times. So if you transfer, you have one sound. If I damage it again, the sound is a little bit more intense. If I damage it again, it's a little bit more. If I damage it again, it's a little bit more. So there is some. You have a little bit of combos. If you make the enemy get further away from winning, or if the enemy increase or moves you further away from winning, and do that in successive like rounds, like one round after another, you build up a combo, and the sound increases to just make you a little bit more aware of, okay, either like on a minute, yeah, I'm like hurting the enemy, and that's just a little bit of fun, or like the enemy is hurting me, so just I have a little bit of an increasing sound cue and audio feedback. It just tells me, oh, it's getting a little bit more dangerous. My number's really increasing, even without looking or not thinking about it. Just the sound gets a little bit more intense, so just I have a little bit more feedback there. So that's handled here. And then if we not already have one, the enemy just draws a new card. So you just draw a new card from the deck, and you just give the enemy a new card. And that's all we do when an enemy turn happens. And then we look at the enemy controller. So in the enemy controller, again, we play we call our play function. The play function just clears a little bit of state. then we go over all the cards in our hand and we evaluate the card of our hand. That is the most important thing that we're doing pretty much in the eye of the opponent. We just go over all of the cards and then we store in a dictionary. We have a dictionary with like the card data and the float. And so we go over the cards in the hand. And for the card, we calculate an evaluation value for the card. And an evaluation value is positive if the card is beneficial to play for the enemy, and the more positive, the better it is. So a value of 2 is better than a value of 1. A value of 1,000 is a lot better than a value of 5. A value of 0 is not doing anything, like nothing changes, there's no benefit, and also no downside on playing a card that has a value of 0. And a card with a value of a negative value is a detriment to the enemy in this case, so to playing it. It's bad to play the cards. You only want to play positive cards, and that the evaluation function is pretty much the most important part of like the eye of the enemy. And what I'm doing, we just have our evaluate card function that just gets the card data. We just create like the states from the games. We just create a before state. What is the current state? That's just like the enemy number and the player number. And then we just create an after state that would just set the before state. So at this point, nothing is happening. This would be a score of 0. And then we are simulating the change, how a card affects if we try out all of its possibilities, if there are like, because you have like you had choice cards, and previously the choice cards were actually, these are like the dynamic cards, the target of choice. Before you could actually choose where it goes to, but with like math cards, there are always a choice that's beneficial. So I stripped away choices that were just meaningless to make. So he just goes through all the targets. So a player card is simulated on himself, the enemy card is simulated on the enemy, the all card is simulated on all, the dynamic card is simulated then just on who that affects, and the store card also. And after we have done this if logic that just goes through the difference how this card can possibly be played. And after that we have a state, and we just have the state of, okay, if I play this card, what is the before state on me, and what is the after state, and what is the before state of the player, and what is the after state of so basically how does this card affect the game in numbers. And as it's just a number game and just a math-based game, it's very easy to just simulate the effect of a card and just evaluate it. So now we have, at this point, we have the state or the simulated state of the game. What would have happened if the player would, if the enemy would play the card that it's currently looking at. And after that, so in this values here now is the before state stays the same, but the after state is then what happens after we play a card. And so if after is 0, that's the enemy number. So if we reduced our number to 0, we have 1. So this is good. But if the player now also is 0, so we check when the player is not 0. Because if we would reduce our number and the player numbers, we would have a draw. You can draw in this game if you do it in one turn. So the enemy says, if I reduce my number to 0, but the enemy's number is actually not 0, I just give the evaluation as infinite. So this is like if I have a winning move, this is the best card to play. I just want to win. If the player just wins, this is like the worst card to play to make the enemy win. And so like the player, we are like looking at this from the enemy perspective. So we don't want to make the player win, so just give this a score of minus infinite. And then we're just creating the delta. So how much has changed? How much has the before to the after state changed for myself and the player? So again, we're looking from the enemy perspective. Then we're just looking if we are in the negative, we are flipping these deltas around. And then we are dividing the deltas by the starting number to just have a smaller relation. Actually, this is very unnecessary. I don't even know why I've done this. I just thought it might look a little bit better. Just give me number that's, but I could have just left it as the delta. This is a useless step that I've done for, I don't know, no really reason. I think I've done this because at first I wanted it to be between -1 and +1, but that never really was the case. So you can kind of forget. So we just have the deltas. How much has it moved? And that's kind of what the evaluation is. I'm getting closer to winning the more I move my number and the more I move it towards 0. Which works in this case because we can't have big moves with plus and minus. Like really big moves only come from multiplication and division. Multiplication you only do on the enemy. Division you only do on 2. So big moves on your own number towards 0 are only divisions, and they are most of the time bigger than like plus and minus numbers, where you just move in a fixed number up and down, and the max plus and minus number is 5. All cards go from 1 to 5. There's no number bigger than 5. So the biggest delta from addition and subtraction is 5, while the biggest move in division is, well, wherever you are through a division. That can be really big, and prime multiplication. And then we just have some logic that looks at, because now we have two values. We have like how much does it affect me and how much does it affect the enemy, or like, yeah, how much does it affect the player, how much does it affect the enemy. And because we can use one value, we now have to decide what of these values is more important. And here we just look at if my self-evaluation is 0 and the player is smaller, then we just return the player evaluation. If our own evaluation is bigger than the player evaluation, we return ourselves. If the self-evaluation is smaller than 0, so it's a negative, we're hurting ourselves. But the self-evaluation is actually bigger, so that the player evaluation is even lower than the self-evaluation. We take the self-evaluation because the self-evaluation is better, because if you basically, this is the case where we have two negative outcomes, like a negative self-evaluation and a negative player evaluation, which would in both cases mean that we have hurt ourselves. And in this case, we want to pick the smaller hurt, which is probably not even the best idea, but it doesn't matter either way. And at the end, we just return the player evaluation. So after this card is done, or after this function is used, which we are using here, we now have a number from -infinite to +infinite, where everything positive means this card is good, and everything that's bigger than another positive value is better, and everything that's negative is bad for us to play. Now we know how good our cards are, and now we have that on an individual level. Now we have to compare how we look at these values in, like, which of the cards now do we want to choose. Now we know, okay, we have an evaluation, we have a number on each card, how good each card individually is. Now we need to look at, okay, what is the best card of the 3 that we can play. So we just do basically a normal bigger search. So we just say the biggest success, we start with -infinite. We are looking for a card that is bigger or better than a -infinite card. And we just have a reference for the best card. We just go through all of the cards, and we just look, is the evaluation of the card bigger as our biggest success? And if we have one, we set the biggest success to the current evaluation, and we set the best card to the card. And after we have run through that, we have the card that has the biggest evaluation. So in that sense, the best card to play. Then we just create our response object. We also just set the card that we will play. Then we look at if the biggest success is actually negative. So if the card that is the best card of the hand to play, so the best of the 3 cards that we can play, if that card is a bad card for us to play, it would just hurt us, then we just store it. So we then just do the storing. We just set the response to that we are playing it on the store, and that it is a store play, and we just return the response. And otherwise, if it's not a negative, so it's not so negative card, we play the card. And when we play the card, we just execute depending on what's the target. We just change the data on the, so we just play the cards on a player data and then remove the cards, and depending on what target it is, we play it on whatever. So we just do the data manipulation on our data objects, and it basically is the enemy eye, and that covers the most important parts of that game. I think that is now also enough for the day, and I will leave it as here. I had a lot of fun with this game, and I think this practice was also quite fun. I don't know how long it was, but I wish you a nice